Hello, I'm about some work my colleagues at the Open Islamic Text Initiatives have done developing new methods for training handwritten text recognition systems that we call Automatic Collation for Diversifying Corpora, or ACDC. And the idea is to complement the usual paradigm of training systems to transcribe handwriting. For instance, complicated Arabic scientific manuscripts like the British Library had a competition on a few years ago. In that paradigm that the British Library and others adopted, we use training data from a manuscript in order to train a model, and then we transcribe the rest of that same manuscript. In their case, even in that case, for these really complicated manuscripts, the performance was not perfect, but still, this is the usual paradigm, right? That you need enough material from the same manuscript in order to build good transcription systems. In our work, which is complementary to that paradigm, we observe that in any very large collection of manuscripts or other books, there will be some books that are copied widely. For instance, the most famous collection of Persian poetry by Hafiz is well represented in lots of collections of Persian manuscripts. So if we could train models on these widely copied manuscripts, we could use them to transcribe other manuscripts that are not so widely copied. And the basic idea behind the ACDC system that we developed is this. First, we start out with a collection of manuscripts and some already transcribed texts or digital editions of works that we think will be widely copied. Then for these manuscripts, we use a model to extract the images of lines from them. We have some initial OCR model that transcribes those lines. We then align those OCR transcriptions with the digital editions and then classify some of those lines as being sufficiently close to the digital editions that we can use them for training data. So for those lines that make it all the way from the beginning of the process on the left to the end of the process on the right, lines like that one, we can then take the line image corresponding to that line and the appropriate line in the digital edition, the appropriate passage in the digital edition, and use it to train new OCR models. And we could start the process all over again. We can iterate this process a couple of times. Now, there will be some manuscripts where our existing line extraction models work well, ones that work well for the most part, except for other things like rubricated or red text that isn't seen well in the print editions we train these baseline models on. But even for pages like this, again, a page from the Gulistan where there's lots of commentary in the margins, which the model that we're starting out with doesn't work well on, we can still extract, some lines, in this case, one line from this very complicated page, which the process was able to use as training data. And what we get at the end of this process is, in addition to a new OCR model, a collation between these manuscripts and, other versions of the same text. We don't need to tell the system, which manuscripts are the same. The collation finds it for us. In this case, the text that we're focusing on from a manuscript in Berlin collates both to another manuscript in Leipzig as well as to an existing electronic edition of this lexicographical text. And for our purposes, we use the alignment between the target manuscript and the digital edition to train on. But what we also get as a byproduct is a collation among the various manuscripts. So you can see these two manuscripts differ by the addition of that one word highlighted in red in the Berlin manuscript as compared to the Leipzig manuscript, which doesn't have that word. Okay, so now let's talk about the actual software that we've released for doing this, distantly supervised training, as we call it. These are some packages that we've released on GitHub. First, the code that we're going to use for training. The training data, a collection of manuscript page images, as well as some manually transcribed lines from those pages. We won't use them for training, but we use them to evaluate how well the training is doing. We also have a completely disjoint test set that isn't drawn from any of the widely copied text, so we could see how well these models generalize to manuscripts and texts that were not used in training. And finally, some of the baseline and retrained models in that final package, which you can use to get your own process started, although you can use your own starting models as well. And so I've checked out these packages in my local directory. I'm not going to use the test data in this demo, although I'll talk about it a little bit later, right? So I've checked out this ACDC training package, the ACDC results, and the Arabic manuscript data. And then I've made another directory, which I've called run. The name isn't important. That's where I'm going to run these demonstration experiments. And the first thing that I'll do in running this demonstration is create a subdirectory called electronic texts. And for this demonstration, I'll just put a plain text transcription of 5 widely copied Persian and Arabic texts in this subdirectory. The names indicate what text they are. All that's important is just the names of the files be distinct. And in this case, they're just plain text. We can have new lines in them. We can have other things in them. But and you could use JSON data instead. Read the documentation for more about how to do that. But the easiest thing is just to make plain text files. These can be relatively long. All that's important is that, separate texts live in separate files. Or even if two texts, if two sections of text don't need to be ordered when they're copied, something like surahs in the Quran or books of the Bible, you can make those separate files as well. And then the other input that we need to organize here is a set of page images that we're going to start this training bootstrapping process on. For purposes of this demo, just to make it short, I'm going to start just with 5 page images from a single book. So in a subdirectory of this run directory called images, and that name is important, I've made a subdirectory for one particular book. It's this Berlin manuscript that I referred to before. And, for brevity, I'll only have 5 page images to start out with. Obviously, to really run this ACDC process at scale, you might want, lots of different manuscripts and, all of the pages from all of these manuscripts. You can do this with PDFs as well as raw PNG page images. You can read more about that in the documentation. Okay, and so finally, the final thing that we need to start out this process, as you recall from that diagram, is a starting line extraction model, or layout analysis model as it's also called, and a starting transcription model, or OCR model. And so I've linked to, in this run directory, I've linked to our starting layout model and our starting transcription model. And I've called them by these default names, which we'll see. I've also linked to the make file, which is a set of recipes for how to make each stage in the ACDC process. And then you also see in this directory listing the electronic texts subdirectory and the images subdirectory. Okay, so let's look in that make file and see what things we can configure. So if we just look at the top of the make file, we see that, the starting segmentation model is, our segmentation model. The starting OCR model is our, initial OCR model trained only on print data without any manuscript training. Obviously, if you're working in, manuscripts that aren't Arabic or Persian or something like that, you would need your own, starting models, perhaps trained on print or perhaps trained on some manuscripts that you actually annotated by hand. The other thing you'll note here is I could uncomment a line. If I had a GPU on my machine, I could uncomment that line for the device, the GPU device that Kraken, the OCR system, would use. And then there's another line for the amount of memory that, the Apache Spark, job control system would use. Will default to 4 gigabytes, but if you have very large electronic texts or, very, very large pages, you might want to increase that memory by a little bit. Okay, so then we'll just run the default make process, which we do by saying make all. That's going to, by default run 3 iterations of that ACDC process, whereby we decode pages with OCR, we align them, and then we create new training data and retrain the model. And this will go through that process 3 times by default, as I said. And it starts by running the initial baseline model that, see that pre-trained layout model and the pre-trained transcription model on those initial page images, only the 5 that I'm using for this demo. And after a little while, we see that we now have these 3 iterations. So the initial baseline print model, and then the first generation and the second generation of retraining. And if we look inside that second generation folder, we see various Kraken trained models. Kraken uses held out data to pick the best one, ft_best.ml model. If we look at the error trace from training, we can see that it converged on this very small amount of data, 67 trained lines that it was able to extract from these 5 pages after 29 iterations with a held out accuracy of 90%. So how well, in fact, has this training process on only these 5 pages worked? Well, if we use our initial print transcription model and decode our manual transcription of these 5 pages from these books, we'll see that it gets 70% character accuracy rate, whereas training for 3 iterations on only these 5 pages was able to improve significantly up to 78.13% accuracy on these 5 pages. So even without any annotated data at all, and with only 5 pages of training data, it managed to find corresponding lines in these 5 pages in order to produce new training data and improve the model. So how well would this process work if we scaled it up to more than just the 5 pages in this short demo? Well, in our paper that we published on the ACDC method, we did experiments on a collection of 81 manuscripts which represent copies of 5 texts distributed as you see here. And in order to evaluate the generalization beyond these 81 copies collectively of these 5 texts, we also produced a test set where we transcribed 1,704 lines from 59 manuscripts, which don't overlap at all with the 5 texts that we saw on the last slide. And just very briefly, if we start out this same print-trained model applied to these 59 manuscripts in the test set, there's a wide range of performance, from some very low performance on documentary text to some relatively high performance on fairly straightforward prose text, but on average, we get only 60% character accuracy. If we had transcribed some of the data from our training set by hand, this is the usual supervised training paradigm, we could increase that accuracy on the test set to 76%. So note, this isn't the usual story where the training and test data are drawn from the same manuscripts. We draw the supervised training data from one set of manuscripts and apply them to a test set from different manuscripts. But if we don't have any manually annotated data at all, but only use ACDC to retrain our models on the basis of the test set, we can still do better than that. So without any manually annotated lines at all for these manuscripts, we can still achieve 80% accuracy on the test set. So we did experiments on Arabic, Persian, and other Arabic script manuscripts. You can use this method on any other script that you want, as long as it's supported by the Kraken OCR system, and you have a baseline model to get the process started. So in order to get our code for retraining ACDC, as well as the training and test data that we created for Arabic, here again are those GitHub repositories that you can use. Thank you very much.